In this video, I'll go over how to operate a vacuum oven that's equipped with Watlow EZ. First, this project is to anneal some plastic. The specification is temperature rise has to be less than 5 degrees per minute and stay within 90 degrees plus or minus 3, as you can see in the graph. And the difficulty I face, maybe other people doesn't have this problem, but for this vacuum oven, when we set at 90 degree, the temperature will keep climbing, overshooting to 110 before settling down, and it takes a long time. My guess is the way vacuum oven was designed, since it's a vacuum, there's no air circulation inside the oven, so the temperature rise and fall is very slow. So by the time it reaches set point, the heating filament is very hot and there's many residual heat in the wall of the chamber and other areas, so the heat keep moving in and the temperature keep rising. Also, this video I'll also show quickly how to operate the Watlow EZ because it took me some time to figure out. And it's always a pressure in work environment because the management doesn't really want you to spend time figure things out. And I want to add more that being a vacuum oven, the interior chamber is completely sealed. And when it's in vacuum, I'm thinking the only way the sample will get heat or will be by radiation, kind of in space. That's why it takes a long time. And that's why even after turning off the heat, the temperature will keep overshoot beyond the set point. There's 3 modes of heat transfer: conductive, that's through contact, convection by circulation of fluid, air, or water, then radiation, so like the sun. So when you're in space, satellites receiving sun rays will get heat up. Conduction. Example of conduction would be you place your pot on an electric stove and the heating element heating up and heat up your stove. And convection would be you heat up the air and blow the air into the chamber, or it would be like the heater in the room, or it first heats up the air and then blow the hot air into the room. So in this vacuum mode, it couldn't have either of that. It can only, I'm assuming, rely on radiation heat transfer. So this was the final result, a very nice graph, and the ramp up and down. The ramp up is 2 degrees per minute. The ramp down probably less than 1 degree per minute because it takes very long time by shutting off the heat. This log was generated from the Watlow D4T, the data logger on board, using USB. So make sure you have one USB did not work and another USB provided the IT was able to be detected. The write mode, when you start recording, it will the button will change to stop recording. That's when you know it's working. When I first put my USB, the icon did not change and I couldn't figure out if it was recording or not. I haven't checked the file format on the USB, but I'm assuming the USB that works has a smaller storage size. It only has a 500 megabyte and is probably a FAT32 format instead of the NTFS. So give it a try if you couldn't get the data logging to work. Right now heat is at 100% at 45 degrees. We're going to turn this off and let it coast. So you see it now goes to 0 and we will see the temperature will keep rising. This will prevent it from overshoot. So we try to zoom fit, so this is a 1 minute increment. Then you can see now it's climbing. When it gets to level off to be near horizontal, then we'll check how close we are to the set point. So we don't want it to be climbing at steep rate if it's already near the set point, that it will overshoot. So as you see, the slope is not as steep as before. During this view, you can see how fast it's climbing over a 1 minute period, and use the pen to keep it in view. This is a bit trending down, but it's okay. We're very close to the set point. So now it's throttle around 33. I don't know if it will power up or down. And we are at 87. Our set point is 91 with deadband of plus or minus 1. And we want to keep within plus and minus 3. Now we have reached set point. The graph looks nearly horizontal. And here we have 0 input in heat. That's what we want. Set point is 91, deadband is 1, so it's still within the deadband. We're in auto, which means you will turn the heat on and off to reach the desired set point. And then we can zoom out on this graph to see. So we climb nicely and without overshooting. Oh, think of this as a up and down to go through the different menu. And this one is to select it, so it's not very obvious, plus it kind of throw you off with weird looking symbol. And to go all these functions, so auto tune, integral, derivative,
proportional band, dead band, true tune, and that's the end. So to enable this menu, press these two buttons, but I will press this first for 6 seconds. And then you go in the menu, make sure, oh, this is actually up. Make sure 1 and 2 set as the same, and 3 and 4 and so on. So 1 is process, actual process. Oh, set point. Three is heat power. 4 is also heat power. So